I was watching a video from Japan when it happened. A crowded train platform, totally normal. And then all at once, every single phone screamed the same harsh alarm, hundreds of them echoing off the walls. People froze, bracing, grabbing railings. And about 10 seconds later, the ground started to shake. 10 seconds. Everyone already knew. The machines had warned them before the earth even moved. That broke my brain a little. How do you detect an earthquake that has not reached you yet? How do you sense something violent and invisible happening maybe 100 miles away and know it is coming before you feel a thing? It feels like a very modern superpower. Satellites, sensors, supercomputers. So I went looking for who first had this idea to build a machine that could feel an earthquake a human could not. And the answer is almost 2,000 years old. Around 132 AD in Han Dynasty China, a man named Zhang Heng built a giant bronze pot covered in dragons. And one day, one of those dragons dropped a small bronze ball from its mouth, pointing toward an earthquake that had struck hundreds of kilometers away. An earthquake nobody in the city had felt. It was the first earthquake detector in human history, doing in bronze the exact same job as those screaming phones. So in this video, why earthquakes were a special nightmare for the ancient world, the genius who refused to blame the gods, how this dragon machine worked, the day it proved every skeptic wrong, and how its idea is in your pocket right now. Let us listen to the earth. To understand why this machine mattered, you have to understand what an earthquake was to an ancient person. Almost every disaster gives you a warning, or at least a reason. A storm, you see the clouds. A flood, the river rises. A fire, there is smoke. But an earthquake, nothing. A perfectly clear, calm day, solid ground, the one thing in the entire world you are taught to trust, and then it betrays you. No clouds, no warning. No enemy you can fight. The ground itself, the very definition of stable, just turns to liquid for 30 seconds and tears your city apart. For most of history, that left only one explanation. The gods, or monsters, or the cosmos itself was angry. In ancient China specifically, an earthquake was not just a disaster, it was political. The emperor ruled by the mandate of heaven, the idea that the heavens approved of his reign. So a great earthquake could be read as a cosmic performance review. Heaven is displeased, the emperor has failed. Earthquakes literally shook thrones. And there was a brutally practical problem too. China was enormous. If a quake flattened a province hundreds of kilometers away, the capital would not know for days, even weeks. News traveled at the speed of a galloping horse. By the time a messenger arrived, thousands could already be dead with no aid on the way. Imagine knowing a disaster has happened somewhere out there right now and being completely blind to where. That blindness is the problem Zhang Heng decided to solve, not with prayers, but with a machine. So who builds the world's first earthquake detector in the year 132? Not a priest, a scientist, arguably one of the greatest minds the ancient world ever produced and one most people in the West have never heard of. Zhang Heng was a Han Dynasty polymath, and polymath barely covers it. He was the chief court astronomer. He cataloged over 2,500 stars. He built a water-powered armillary sphere, a rotating bronze model of the heavens, driven by a steady drip of water that turned in perfect time with the real night sky. He calculated pi more accurately than anyone in China before him. He was a celebrated poet. But here is the part that matters most for our story, his mindset. In an age when an earthquake meant the gods were angry, Zhang Heng quietly insisted that these events had natural causes, that the world ran on rules you could measure, not moods you had to appease. That is a genuinely radical idea for the year 130. He looked at the most terrifying, most supernatural seeming event imaginable, the ground ripping open, and thought, that is not a god, that is motion, and motion can be detected. He could not stop earthquakes. He could not predict them. But he realized he might be able to build something that could feel one the instant it began and tell him which direction it came from faster than any human messenger alive. So he did. What he built was honestly a work of art. Picture a huge bronze vessel, almost 2 meters across, shaped like a fat wine jar with a domed lid, heavy, ornate, gleaming. The records even tell us it was engraved with mountains, birds, and ancient writing. It would have dominated the room. Now, around the outside, spaced evenly, are 8 dragon heads, one pointing in each of the 8 directions, north, northeast, east, and so on, all the way around. Each dragon is cast mid-snarl, and each one holds a small bronze ball balanced delicately in its jaws. And directly below each dragon, sitting on the ground, is a bronze toad, squat, mouth wide open, head tilted up, waiting. 8 dragons above, 8 toads below, frozen in a staring contest. For years, in normal times, nothing happens. The dragons hold their balls, the toads wait. It just sits there, this strange, beautiful machine, in the Han capital of Luoyang, looking more like a religious idol than a scientific instrument. And that was exactly the problem. To everyone watching, it looked like superstition, a fancy bronze ornament that supposedly could feel the earth. Most officials almost certainly thought it was nonsense, because the genius of the thing was completely hidden. The real machine, the part that did the work, was sealed inside where no one could see it. So let us open it up and look at the secret that turned 8 bronze dragons into the first earthquake detector on Earth. Quick one before the good part. If a 2,000-year-old earthquake detector is giving you chills the way it gives me chills, that is this whole channel. Subscribe, and the next everyday thing in your life gets the same treatment. Okay, inside the bronze jar, the secret is one simple, beautiful idea: inertia. Picture a heavy column, essentially a pendulum, standing balanced in the very center of the vessel. The exact internal design was lost to history, and people still argue about the details, but the principle almost everyone agrees on is this. Normally, that central column sits perfectly still, perfectly balanced. Then an earthquake begins somewhere far away, and a seismic wave races through the ground and reaches the machine. The base of the vessel, sitting on the earth, suddenly jolts in one direction. But the heavy column in the middle does not want to move. That is inertia, the same thing that throws you forward when a car brakes hard. So for a split second, the ground moves and the column lags behind, leaning relative to the jar. And here's the clever part. It leans along one axis, the line of the wave, pointing back toward where the earthquake came from. That lean nudges a small lever, which connects to just one of the 8 dragons, the one facing the source. Its jaws open, the ball drops, and it falls into the open mouth of the toad below with a loud, unmistakable bronze clang. In a quiet palace, that single clang means an earthquake has begun. It is real, and it came from that direction. One sound, one direction, from a tremor no human in the room could feel. For a while, the machine just sat there, and the skeptics felt safe. Then came the day that made Zhang Heng famous for the next 19 centuries. One ordinary afternoon in the capital, with no warning and no tremor that anyone could feel, one of the dragons opened its jaws. The ball dropped, clang, into the toad facing the northwest, and nothing else happened. The ground did not shake. People in Luoyang felt absolutely nothing. So the court did what courts do. They scoffed. The thing was broken, a toy. Zhang Heng and his ridiculous bronze pot had finally embarrassed themselves. An earthquake you cannot feel is not an earthquake. The criticism was loud, and for several days it looked like the machine had failed in the most public way imaginable. And then a messenger arrived, galloping in from the northwest, exhausted, carrying news. A powerful earthquake had struck Longxi, a region hundreds of kilometers away, in roughly the direction the dragon had pointed. Days earlier, at almost exactly the moment that ball had dropped, the machine had not been broken. It had felt an earthquake that was completely invisible in the capital and correctly pointed across hundreds of kilometers to where it happened, long before any human messenger could possibly arrive. The scoffing stopped. The officials were, by the accounts, astonished. A bronze pot had sensed a disaster no person had felt and announced its direction. The first time in history, a machine knew something about the Earth that no human did. Now let me be honest about what this machine was and was not, because the truth is more interesting than the legend. It was a seismoscope, not a seismograph. That difference matters. It could tell you 2 things: that an earthquake had occurred and roughly which direction it came from. That is it. It could not tell you how strong the quake was. It could not record anything over time, and it could not, despite a lot of myths, predict an earthquake before it happened. It only reacted to the first wave faster than a human could. It had real limits too. It probably needed a fairly strong, fairly distant quake to trigger cleanly, and the exact mechanism inside is genuinely lost. The original was destroyed centuries ago, and everything we know comes from a few paragraphs in the historical records. Modern engineers have built reconstruction after reconstruction, still arguing about whether it used a hanging pendulum or an inverted one, and some early replicas, frankly, did not work very well. But none of that shrinks the achievement. Strip away the dragons and the legend, and what Zhang Heng actually did was profound. He proved that an instrument could detect a distant, invisible ground motion and pull real information out of it, direction, automatically, with no human judgment involved. He turned an act of the gods into a reading on a machine, and every seismic instrument that has existed since is at its heart doing the same thing he did first, holding perfectly still so it can feel the earth move. Which brings us back to those screaming phones in the train station. A modern seismometer is, at its core, exactly Zhang Heng's idea: refined, a mass that wants to stay still while the ground moves around it, and a way to measure that relative motion. We just swapped the balanced bronze column for a tiny suspended mass and a laser or a coil, and the dragon's jaws for a stream of digital data. But the deepest echo is the earthquake early warning systems now running in Japan, Mexico, the western United States, and beyond. Here is the trick they use. An earthquake sends out two kinds of waves: a fast, weak one that arrives first, and a slower, violent one that does the damage. Sensors near the epicenter catch that first fast wave, instantly work out that a big quake has started and race an electronic alert at the speed of light ahead of the slow destructive wave. That is the 10-second head start those phones had. Trains brake automatically. Surgeries pause, gas lines shut, people take cover. And increasingly, the sensor catching that first wave is not some giant lab instrument. It is the accelerometer inside ordinary smartphones, millions of them, quietly forming the largest earthquake network on Earth. So the next time your phone buzzes a warning, or you just see it happen on a screen, picture this: a bronze dragon almost 2,000 years ago, opening its jaws and dropping a single ball toward a disaster no one could feel. You are holding its descendant. We still cannot stop the earth from shaking, but thanks to an idea born in bronze, we can finally hear it coming and point at it. That is the everyday equation. I will see you in the next one.